Good afternoon, class. Welcome to today's podcast on lesson 5.3, Angles of Polygons. In today's lesson, you should be able to find the sum or total degrees in a given polygon. So let's take a look at our first example. We have a polygon. It is a pentagon because there are 5 sides. We want to know how many total degrees, or the sum of the measure of the angles in a polygon. The first thing that you can do to solve this problem is to divide the polygon into triangles. I'm going to pick the bottom left-hand corner or vertex. It doesn't matter which vertex you pick, which I'll show you in just a second. Starting the bottom left-hand corner, I'm going to divide my polygon into triangles. You should be able to see that my polygon is now divided into 3 triangles. If you say, Mr. Phillips, I don't want to start in the bottom left-hand corner or vertex. Okay, so I will start in the bottom right-hand corner or vertex. I will divide the polygon into triangles. You should still be able to see it divides into 3 triangles. You do need to be careful if you're going to apply this strategy, because I've had students in the past say, all right, I'll start in the bottom left-hand corner and start dividing the polygon into triangles. But then, for some reason, they want to switch to a different corner or vertex. Guys, you have to be careful. You cannot do this. Notice in the first 2 examples, my line segments do not intersect each other. If you do it this way, right here they intersect or touch. That will cause you to get the problem wrong every single time. So if you're going to use a strategy, please be careful. Pick a corner, stay in that corner. Don't switch to a different corner and be inconsistent. You should be able to see that there are clearly 3 triangles in this pentagon. If I want to find the sum or total of the angles, you should remember there's 180 degrees in every triangle. Since I clearly have 3 triangles, I'm going to multiply by 3. That will give me a total of 540 degrees. That means any 5-sided polygon or any pentagon has a total of 540 degrees. That's the first strategy. Now let's take a look at a second strategy for solving the problem. In this strategy, you will use a formula, then you will plug and chug. If you use the formula and plug and chug, the first thing you need to do is count up the number of sides. There are 5 sides in this polygon or pentagon. So I'm going to say that n stands for the number of sides. In this example, we have 5 sides. So I'm going to say n equals 5. Now I'm going to plug and chug. Put 5 in for my variable n. So I end up with parentheses 5 minus 2 parentheses times 180 degrees. Remember, guys, we always do the order of operations until the Cubs win the World Series. Order of operations says do what's inside the parentheses first. That gives me 3. When I multiply 3 by 180, I get 540 degrees. If I scroll back up, you should see plugging and chugging into the formula gave me 540 degrees. Dividing the polygon into triangles also gave me 540 degrees. Both methods work. This is the formula that you will use for plugging and chugging. Remember, n stands for the number of sides on the polygon. S would be the sum or the total. So we would say for this example, the sum of the measure of the angles, S equals 540. When you take the FCAT, if you forget what the formula is, All you have to do is look on your reference sheet. The FCAT writes the formula slightly different, but you'll still get the same results. For example, they write 180 parentheses n minus 2. Remember back in the example that we did, n was the number of sides. We had 5 sides. So here, I will plug and chug. We said n is equal to 5. I'm going to put 5 in for n. Don't forget to put your parentheses. And I have 180 because there's 180 degrees in every triangle. Remember, due to order of operations until the Cubs win the World Series, so I have to do what's inside the parentheses first. 5 minus 2 gives me 3. 180 parentheses 3 means 180 times 3. When I multiply that out, I get an answer of 540 degrees. So there are 540 degrees in any 5-sided polygon or any pentagon. Okay, let's take a look at another example. Our second example asks us to find the sum of the angle measures of the green polygon. If you want to divide the picture up into triangles, I'm going to pick a corner. Remember, it doesn't matter what corner or vertex you pick, just be consistent and don't change in that problem. I'm going to start drawing my line segments. Notice my line segments do not intersect or touch each other. Now you should be able to see that I have a total of 5 triangles inside this polygon. Remember that there's 180 degrees in every triangle. Since I have 5 triangles, I'm going to do 180 times 5. That means that in any polygon with 1, 2, 3, 4, 5, 6, 7 sides, any polygon that has 7 sides will have a total measurement of 900 degrees. Or you can say, Mr. Phillips, any heptagon will have a total of 900 degrees. I'm going to work the same problem, but this time instead of dividing it up into triangles, I'm going to use my formula and plug and chug. We said that there were 7 sides to this polygon, or there's 7 sides on a heptagon. Here's the formula that I'm going to use. Remember, on the FCAT, if you forget the formula, just look on your reference sheet. Since there were 7 sides, I'm going to say the number of sides, n, equals 7. Now I'm going to plug and chug into my formula. Do what's inside the parentheses first. Now I'm going to multiply 5 by 180 degrees. When I do that, it gives me an answer, again, of 900 degrees. So any 7-sided polygon, any heptagon, has a total of 900 degrees. Remember, if you do plug and chug, you should get 900 degrees. If you divide the shape up into triangles, you still get 900 degrees. Both are valid strategies. You pick the one that's easiest for you. Hope this podcast helps you determine the total amount or the sum of the angle measures of any given polygon. Stay tuned for our next podcast where we find a missing angle inside a polygon.